My name is Santos, and I'm going to explain how does the circuit of a boost converter function. We have to know that this circuit has two steps. The first one is when the switch is on, and when the switch is on we have this circuit. So the capacitor is going to work as a source because the current doesn't pass by the diode. So the capacitor is going to give a current that is going to pass over the load. Also, the inductor is going to store energy during this process. Second, when the switch is off, we have this circuit. And what happened here? The capacitor is going to store energy, right? Because the inductor is going to work as a source. Why? Because it's going to give the current that is going to pass over this side of the circuit and give the current to the load. Alright, as we know how functions the circuit of a boost converter, now we are going to know how is the behavior on time of the current that passes over the inductor. And we have to know that on time the voltage that is over the inductor is described by this equation. That means or represent that this voltage is equal to the rate of the current of the inductor and its inductance. So we have something interesting here, and is that this voltage doesn't have extremely changes on time. That's the reason why this current has a linear characteristic. Okay, now we have the applications of the boost converter. First, to increase the voltage and reduce the number of battery cells. But what it means? Okay, when I have something that needs a high voltage on the load, we are not going to use a lot of batteries. With this circuit, we can use just a few batteries and we are going to have a high voltage on the output. Okay? Right now, we have the hybrid vehicles. Some vehicles needs about 500 volts to work, but we don't have a battery that give me 500 volts. So we work with batteries that give me 250 volts on the output. And with this circuit, with the boost converter, we made that this voltage be higher to the 500 volts. Finally, we have DC light systems. And how does it function? As we see on the first application, we are going to use just one battery or two batteries to have a voltage that can give the current necessary to start working on a diode. And that are some applications of the boost converter. Okay, finally, I'm going to explain which are the advantages of the boost converter over the other converter. Okay, first, the boost converter is more efficiently than the boost converter, who has the 10% less efficiently than the boost converter. Second, the voltage that is in the in has the same polarity that the voltage that is on the load. And this is property of the boost converter. And this doesn't happen with the boost converter. Third, the current of the boost converter is continuous, which is desirable for PV or batteries that will be on the load. And this characteristic is compared with the boost converter. Finally, we have to know that the switch has a common ground, and this is property of the boost converter.